11 point says 7 systems of inequalities. I'll do most of the explaining here through examples, so let's graph this inequality. Well, the best way to do that really is to consider an equation, move this into a format that looks a little bit more like something you're familiar with. That's a quadratic. There's a vertex here, the -2, so up 1 over 1, up 1 over 1. So the next one should be 1 and then 3, so 1, 2, 3. So there, symmetry. And then now I can make this into sort of the inequality part. So this is a less than symbol. And less than symbols and greater than symbols will be graphed with a dotted line. And the reason that the line is dotted is because the line is not part of the solution set. And I wrote maybe a little bit too far, but on this one I don't really have a system, I just have one. So here's the parabola, and it said less than, and less than means that I want solutions that are points that are below this parabola. So below would be from the parabola on down. So here are a bunch of things that are below. So I'll graph a couple more here. Okay, so what does it mean to be a solution? Well, it means that any dot that fits in or that comes out of the shaded area should work in the inequality. So if that's -1, -2, so let's say that's a -2, -3. So when I plug that in, so when I use a -2, -3, and I plug that in here, then I should get an inequality that works. Now keep in mind that this is sort of backwards. So x is a -2 squared, less than a -2. So -3 minus 4 is a -7, and that indeed is a less than a -2. So it worked. Okay, so that's an inequality in 2 variables. So this is then a system, because a system implies that you have more than one. So let's use blue for this one. Alright, so let's graph this. Well, that's a straight line, and the easiest way for me to graph it is to graph this one. So 1, 2, 3, 4, 5. I get a dot here, and it says down 3, 1, 2, 3 over 1. And down 1, 2, 3 over 1. We'll put some tick marks over here. So 1. And then I'm going to graph it. And I get something that looks like this. Okay, so there's your first one. Okay, it says less than or equal to, so I'm going to use tick marks. And I think I just skipped over the fact that I did use a solid line here. Okay, so I used the solid line because it says less than or equal to, and with a solid line, the line is going to be a part of the solution set. So that means a dot on the line should work. Okay, second one, I'm bringing the y over for that one as well. 2x then becomes positive. So that has an intercept of a -10. I already drew that. And then if x is 5, 2 times 5 is 10 minus 10 is 0. So 1, 2, 3, 4, 5. So there we go. And I think this one is also I'll cheat a little bit, I missed it there. So this one also is solid. Yep, this one says greater than, so let me tick mark above. And then where the below and the aboves meet, sort of, that's the area that I'm interested in. So all my solutions will come out of this area. So let's shade that area in a little bit. Sorry, it's not the prettiest. There we go. Okay, so shaded area. And I just said that any dot in this area should work. So for example, 0, 0 clearly works. Now keep in mind that when you fill it in, it works for both of these. So 0 plus 0 is 0 less than or equal to 5. Yes. 0 plus 0 is 0 greater than or equal to -10. So yes, it works. But I wanted to pick a dot that was actually on the line here. So at 1, I should be at 2 according to my graph over here, right? Okay, so that implies that 1, 2 should work. So 3x plus y is less than or equal to 5. I put 1 in here, I get 3 plus 2 is less than or equal to 5, and 5 is equal to 5, so that's a true statement. Okay, and if I use 1, 2 in the other one, so negative 2x plus y is greater than or equal to negative 10, so that's a negative 2 for, let's see, we're using 1, 2, right? And then plus 2 is greater than a negative 10, and a 0 greater than or equal to a negative 10, and that's true as well. So that seems to work. Right, then there's only one thing left, and that is I should probably find out what this spot is, because that's where they cross. Now, you know, it looks like it meets perfectly, so I could probably count it off, but I should also be able to solve for this. So if I equate these two things, if they're both equal to y, then they must be equal to each other. Move that over, so that's 5x, move the 10 over here, that's 15, so x is equal to 3. If x is equal to 3, then let's see, 6 minus 10, that's a negative 4, and that's pretty consistent with the picture that I drew. So there you go. Alright. Let's make it a little bit more interesting yet. Let's include things that are not straight lines. So x squared minus 9, that's a parabola that goes through 9 on the y-axis. So that's 5, 6, 7, 8, 9. And from there, it goes up 1, and then it goes up 1, 2, 3. Then it goes up 5. That's easy. So I can mirror that over here. So 1 here, and 1 there. Now let's look at the straight line. 2x plus y, I need to go a little further because it's going to go through 4. So I was at 5, right? So 1 and 7. So 2, 3, 4, 5, 6, 7. We'll use symmetry over here. And then check here. So solid line for this parabola. Actually for both of these. So parabola is going to look a lot like this. Missed that a little bit, but oh well. Okay, we'll pretend I got that dot a little better. Wow, that's awful. Okay, yours should look prettier. It's a little easier to do with a pencil. All right, 2x plus y equals or less than or equal to 4. So when x is 0, y is 4. So 1, 2, 3, 4. And when x is 2, y is 0. 2, and you can see that this one isn't going to meet at a nice point because that was the intercept, and here's the point at 2, so it intercepts somewhere over there. Let's count it out over here. So 2, 1, and that's not going to look good either. So 2, 1, 2, 1. So this is to the left of that. I know it's ugly, you can barely see it. So somewhere to the left of the negative 4-ish or so. Okay, let's connect that with a straight line. Let's pretend that line is good. It's not horrible. It's not great. Okay, so I'd like to actually know the points where they intersect, but that's going to be a little bit harder to find here and here. Let's actually work on the solution first. So what did we have? Above the parabola, so that's this way, right? And that was a less than or equal, so below. So the shaded area is going to be in here. That actually looks better than trying to color it in. Alright. Okay. I do think we should be able to solve for this. So if y is x squared minus 9, I'm going to replace that with x squared minus 9. I'm going to pretend that we have an equation here. I'm going to reorder this one, bring the 9 over, complete the square, so that means I've got to add an extra 1 over here. Take the square root, so we get plus or minus the square root of 14. And let's see if that works. The square root of 9 is 3. This is almost 4, so let's say it's, you know, like 3.7. When I subtract 1 from that, when I do 3.7 minus 1, I'm at 2.7. So this intersection looks to be okay. So that looks to be, you know, with an x of a negative 1 plus the square root of 14. So I have a negative 1 plus the square root of 14 as one of my x-intercepts. Okay, the other one would be at x is a negative 1 minus the square root of 14. So that's a little past the negative 4 because this was almost a negative 4 and then another negative 1. And that was consistent with the picture that I had over here. Now I should also figure out what the y is then, right? And the y, that comes from here, so keep in mind that I could write this as a negative 2x plus 4. So the y would be a negative 2 times negative 1 plus or minus the square root of 14. And then it says plus 4, right? So I get a negative 2 times negative 1 is 2. This negative doesn't do much here, so it's 2 plus or minus the square root of 14 plus 4. So the y's are 2 plus 4 is 6 plus or minus the square root of 14. So one of these we get 6 plus the square root of 14. Well, the 6 plus the square root of 14 is clearly over here. So that's 6 plus the square root of 14. And then square root of, or 6 minus the square root of 14 is going to be over here. So you can find it. I just wanted you to see that you can. In this case, it wouldn't actually be required to write down where they intersect because it doesn't come out very nicely. Okay, trying to do two things at once. Alright, so what if you have 4 of these? Well, if you have 4 straight lines, it's not that big of a deal. So in this case, it says x plus y is less than or equal to 10. Well, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that is a straight line that will go through 10 on the y and 10 on the x. So there's 10 on the y and 10 on the x. Okay, it's a solid line. So that should look a lot like that. Alright, next one, 2x plus 3y, 24. So if I make y 0, then x should be 12. So 2 times 12, so that should work. Well, 12 is over here. And I can do a different color for that. So we're over here. And if I make x 0, then 3 times 8 is 24. That was 10. So then this must be 8. So I need to connect those two with a straight line. And that's horrible. We'll try it one more. It's not bad, it's not great. And you can see there's an intersection here somewhere. You should be able to find that, right? Because usually we want to mark the corners, and this one says x greater or equal to 0. Well, that's the y-axis, right? So that means to the right of the y-axis. So this is actually part of this graph as well. And y greater than or equal to 0 is an x-axis. So let's tick mark some of these. So this one said what? We needed to be below this. So we're going to be below this thing. The red one also needed to be below. So we want to be below the red one as well. So I actually didn't need to mark that. So I'm actually going to be over here. And then we need to be above or to the right of the y-axis. So that would be here and above the x-axis. So the area that I'm actually interested in is, it's not a triangle because it goes here and then it goes to the red line over here. So it's up to the blue line over here. And then at this point it goes to the red line. So we need to find that point. And if you had done your grid very well, then you can actually see that that's at 6 and 4, I believe. So let's see. These go by ones, right? So 1, 2, 3, 4, 5. So there's 6, 4. That looks to be right. So 6, 4. So we'll mark that as 6, 4. Another corner of our region would be right here on the y-axis. So that would be at 0, 8. And then this point, that would be the 10, 0. Coming from that one, and those are the 3 corners that, well, technically 0, 0 is also part of it. So those are the 4 corners of our solution area. Okay, we'll need that down the line. Alright, last one here. You can do word problems with this. Yay! So let's see what it says. A retired couple has up to $30,000 to invest. As their financial advisor, you recommend that they place 20 in treasury bills yielding 5% and at most 5,000 in corporate bonds, using X to denote the money invested in treasury. So X is treasury, and Y then would be corporate bonds. Write a system of linear inequalities. Right. Well, we know that Treasury plus the bonds has to be less than or equal to 30,000, because that's the most people have to invest. So I'm going to put this grid into thousands. So I'm just going to write 30. What else do we know? We know that the Treasury bills, which is an X, at least 20,000 in Treasury bills. So X needs to be greater than or equal to 20,000. And the corporate bonds, which would be the Y, at most 5,000 in there. So that is less than or equal to 5. And you also got to keep in mind that Y does have to be greater than or equal to 0. So you can't invest less than 0 in corporate bonds. I don't have to worry about an X greater than or equal to 0 here because I already have a greater than or equal to 20 over here. And then now I need to come up with a grid for this. So if I count by 2's, so that would be 10, that would be 20, that would be 30. Can I get more out of that? 40, 50, 60. I can. So we're going to say that this was 10. This is 20. And that's 30. And that should work, right? Because that's the most that I'll have. So 10, 20, 30. So x plus y less than or equal to 30 runs through 30 here and 30 there. So let's see if I can connect those. That's not bad. Say it's not bad because the slope here is 1, so down 1 over 1, down 1 over 1. That seems to work pretty well. Alright, greater than or equal to 20. So this is 10, that is 20, so greater than or equal to 20 on the x-axis, so that's a vertical line through 20 on the x-axis. So keep in mind that this was 10, that's 20, and that's 30. This is 10, that's 20, and that's 30. And this axis is the y-axis, which is the bonds, and it's in thousands of dollars. And this one was the Treasury. How do you spell that? Treasury. And this one is also in thousands. So greater than or equal to 20. So it's a straight line that runs right. Wow. It's a good thing I was going on a straight line here. So there's that one, greater than or less than or equal to 5. So 5 would be here. So we'll use this one as well. And then I need to use some tick marks. So I want it to be below this one. It says greater than or equal to 20, so that would be here so far, and hopefully this is a less than, and that was a less than, so yes. So the shaded area is this tiny little quadrilateral over here, trapezoid, and it has some intersections. They're fairly easy to read off, so sometimes we just call them corners, literally. So what do we have for our corners? We have 20, 0. We have 20, and then that one was 5. And we have the intersection here, which looks to be a 25 and 5, right? And then we have one more here at 30 and 0. So those are the corners. In this case, I didn't put them on there because I really didn't have enough room. So, but that is the system with the, in a word problem like this would often be called the feasible region. And so the feasible region is the shaded area that I have over here. And that's it. Thanks.